When we think of enormous explosions, you might imagine nuclear bombs, erupting volcanoes, or natural disasters on Earth. But in the vast cosmos, there are events billions of times more powerful than anything humanity has ever witnessed. These are supernova explosions and gamma-ray bursts. These two phenomena possess terrifying destructive power, capable of wiping out entire planetary systems in an instant. Yet at the same time, they play an essential role in shaping the universe as we know it today. So what are gamma rays? How do supernovae occur? And can they affect Earth? Let's find out in today's journey. A supernova is a cataclysmic explosion that occurs when a massive star reaches the end of its life. In its final moments, the star's core collapses, forming a neutron star or a black hole, while its outer layers are blasted into space with unimaginable energy. There are two main types of supernova. A. Type Ia supernova occurs when a white dwarf star siphons matter from a nearby companion star, reaches a critical mass limit, and explodes completely. Often used as standard candles in cosmology because their brightness is relatively consistent, helping astronomers measure distances in the universe. B. Type II and IB IC supernova occurs when a star at least 8 times more massive than the Sun collapses after exhausting its nuclear fuel. This type of supernova often results in a neutron star or a black hole. How bright is a supernova? A single supernova can outshine an entire galaxy for several days or weeks. Some can even be seen with the naked eye from Earth, despite being millions of light years away. As frightening as they sound, supernovae are crucial to the structure of the universe. They create heavy elements such as iron, gold, and uranium, elements that cannot be produced in the cores of normal stars. These elements are then scattered into space, mixed into clouds of gas and dust, and eventually form new stars and planets, including Earth, and even your own body. Did you know? The iron in your blood may have been forged inside a supernova that exploded billions of years ago. Gamma rays are the highest energy form of electromagnetic radiation in the universe, with energies millions of times greater than X-rays. They are invisible to the human eye, but can pass through most matter and damage molecular structures in cells, making them extremely dangerous to living organisms. Gamma rays can be produced in many cosmic processes, but the most intense, extreme form appears in events called gamma-ray bursts, GRBs. A gamma-ray burst, GRB, is the most powerful flash of light known in the universe. In just a few seconds, a GRB can release as much energy as the Sun will emit over its entire 10 billion year lifetime. There are two main types. A. Short GRBs, less than 2 seconds, caused by the collision and merger of two neutron stars, or a neutron star merging with a black hole. B. Long GRBs, more than 2 seconds, usually associated with the supernova explosion of a rapidly spinning massive star that collapses into a black hole. These are the highest energy events in the universe since the Big Bang. If a gamma-ray burst occurred within a few thousand light-years of Earth, and its jet were pointed directly at us, it could destroy Earth's ozone layer, trigger mass extinctions by increasing the level of harmful ultraviolet radiation from the Sun, create toxic chemical compounds in the atmosphere. Some scientists suspect that a GRB may have contributed to a mass extinction event around 440 million years ago, although this has not yet been definitively proven. The answer is, it's possible, but extremely unlikely. Some stars in the Milky Way could, in theory, produce gamma-ray bursts when they die, such as WR104, located about 8.000 light-years from Earth. However, for a GRB to significantly affect Earth, its beam would have to be aimed directly at us, and the chances of that are very low. Even so, astronomers continue to monitor massive stars near us to keep an eye out for any unexpected explosions. Telescopes cannot see gamma rays with normal optical instruments, so we use special space-based observatories, such as Fermi Gamma Ray Space Telescope, Swift Observatory. These satellites detect gamma rays the moment they arrive, then immediately alert hundreds of telescopes around the world to observe the aftermath of the explosion in other wavelengths. Some notable GRBs include GRB 130427A, detected in 2013, one of the most powerful GRBs ever recorded. GRB 221009A, observed in 2022. Nicknamed the burst of the century because of its extreme brightness. GRBs are not just cosmic threats. They are also powerful tools for research. They help us observe the early universe. Because many GRBs come from extremely distant regions and very early cosmic times, they allow scientists to study the expansion rate of the universe. They provide clues about how stars, black holes, and perhaps dark matter form and evolve. Many GRBs originate from farther away than almost any other known object, allowing us to look back into the deep past, toward the era not long after the Big Bang. Not every supernova produces a GRB, but many long-duration GRBs are associated with type IC supernovae, where a massive star collapses and becomes a rapidly spinning black hole. You can think of it this way. A supernova is the explosive death of a star, while a GRB is the star's final, most violent flash of energy. Gamma rays and supernova explosions are powerful reminders of a deep cosmic truth. The death of a star can become the beginning of a planet, an element, or even an entire civilization. From the ashes of supernovae, heavy elements are scattered across space, forming planets like Earth, living beings like us, and minds capable of looking back and asking where we came from. We are not just observers of the universe. We are its products, children of starlight, born from the most violent explosions in the cosmos. Milky Way sparkles.